We can put this into our calculators and boom, get the remaining amount.
That's the wrong number.
So you take 21.5, put it in here. I like to put the 0.5 times this, which is raised to that power first, and then multiply that by the 21.5. That way I know my calculator is doing the right order of operations. Yeah?
Wait, how did you multiply 25.3 times 1/2 life divided by?
Because 1/2 life just equals
Oh, you're cross
that.
multiplying, right?
Yeah.
Oh, okay.
Yeah.
For sig figs, like, what?
Yeah, this
Will it limit some sig figs?
right. This does not limit your sig fig. Does not limit sig fig. Because it's kind of like in the definition. Okay, that does not limit it. This will limit it, or this will limit it. So this one only has 3 sig figs. So that's going to limit your overall remaining amount over here to 3 sig figs. Yeah.
What if the number of half-lives was given to you and let's say it was 5? Like, would that limit your sig figs?
If it was just plain 5 without any zeros after that,
Yeah.
and yes, because the way I'm writing these
No,
questions
I'm
is
not,
that they
just
take
doing
into
something
account
else.
sig figs.
I'm just writing
So if
this
it's
out.
5.0000, then
0.5 to the
just use those zeros as significant figures. Yes. Yeah. Yeah.
What do you mean, like, what part do you mean, like, how much?
How much of the initial amount is remaining? That's what I mean.
Oh, so
How much? Yes. It's kind of shorthand for saying how much of the initial amount of radioactive substance is remaining. I know it gets. I just write it for brevity. Okay. Cassandra, you had a question? You okay? Okay, we're fine. Okay. Next.
Can we find the answer, please?
Okay. I don't have a calculator in front of me, so whatever it is, it's going to be on the.
Yes, you do.
Your calculator. Let's do it real quick. I'll do it right here. 0.5 raised. I'll write it on the. I'll do it on the camera. 0.5 raised to 4.425.
Wait, does he have a video like every
Yeah.
Now I'm going to say times
every class right?
0.5. Well, how?
Review.
So the remaining amount turns out to be, drum roll, 1.00.
That's right.
Isn't that awesome? It turns out to be exactly 1.
Should it be 1 or
Did you plan that? You
No,
planned
I
that.
did not plan that. That's how much. And they're usually going to be, yeah, this is in grams, so it'll be in grams.
Should it be 0.9 or 1?
Yeah, he planned that.
I did not plan that. I was just lucky. It should be 1.00. If you had on the test, I guarantee if I put this question on the test, you guys would be saying, "Oh, it's just 1," and you'd give me this, and I'd say, and big red marks would appear on your sheets, and you'd be saying, "Mr. Sam, that's the same thing." No, it's not. This is not the same as that. This has 2 zeros after it. Yeah.
Who's a good fish?
The amount of half-lives.
Who's
Yes,
it for?
the number of half-lives, you mean?
You doing
Yeah.
two reviews?
So what I did
No,
right
there's
here is I
something-
took
There's
this,
something wrong.
1 half-life equals this, and I know that we have this much
What's
seconds
hard,
to
this or
start
that?
off with. I just converted that many
Half-lives.
seconds into half-lives because this acts like a conversion vector right here. So I can say 1 half-life equals 50.92, and I can use these. I can use this right here to convert seconds to half-lives. So that gives you the number of half-lives, and then you can put it over there. Yeah.
Is the initial amount and remaining amount, is the unit grams, or does it not matter?
In this case, it is grams. If I put pumpkins, then it would be pumpkins.
Okay.
Okay? So it's whatever it tells you as you go.
Oops.
Yeah.
I keep moving this back, so I think I should move.
Okay.
Copy sequence.
People are going to get seasick on this.
it has an infinite number of sig figs. So
Yeah.
Why are you leaving me, yo?
Why did you change the 1? Does 1 also have the answer?
No, this is not right.
I don't have an Indian accent.
I said-
that was not right.
Right. Right, that is not right. Yeah. Okay, moving on. We're done with half-lives. Let's talk about isotopes and average atomic mass. Okay, this stuff is crazy. Oh, so crazy. Let's do this. Isotopes and average atomic mass. You know how to do this, right? We have. I'm going to make another problem up right here. This is one that has to do with. Let's do carbon. Let's do carbon 14. Let's say carbon has 2 isotopes. We do 2 isotopes. It's okay. Carbon has 2 isotopes. One isotope is, let's say, isotopes, and I'll do AMU. Let's say atomic mass of isotopes on this little. Let's say there's 2 isotopes right here. I'm going to say one of them is 12.00 or 011. No, just 00. And this one is, let's say, 14.001. How about that?
Is there a tape measure on the big one?
Not sure.
Okay, sorry. I'll look. You go.
Okay, these are AMUs. This over here is the percent abundance, right? Do you want to do the super duper hard one, or do you want to do the super duper okay one?
Let's do okay one for now.
Do the okay one for now. The super duper hard one is when you have to figure out.
Calm down.
The super duper hard one is where you have to figure out the percentages if I give you the overall average. You can do that.
Will you give us that?
You can do that.
It was
The hard one is when I tell you what the average mass is, and you have to. There we go. It's that
What are
one.
you doing here?
Look at those problems. Those are good. Let's do the kind of hard one, but kind of easy one. Let's do the medium size one. Medium difficulty one. Let's say that this one right here is 98 point. I'm just making this up. 98.52% abundant. I give you this information right here, and then I would ask you, what is the average atomic mass for carbon? Okay, what is the average atomic mass for carbon? This is pretty easy.
100 minus 98.
It's 12 times 0.9.
What's the first step? I hear people kind of mouthing the answer, but what is the first step that we should take for this?
100 minus 98.
No, well,
I'm going to have Danielle answer this one.
okay. I'm not sure about this, but you have to
First step?
like convert the percent into like an actual number. The percentage.
Even before that. Yeah,
So you have to find the thing in that blank box.
in this blank box.
That's the 1 point.
Oh, that's not the same problem.
1.48%.
Yes, that's the first step.
And then you're gonna have to convert the 2 abundance into decimals.
Yes.
So you do 98.52 divided by 100, and that's 0.9852.
Right.
And you're gonna do 12.000 in parentheses 0.9852
Right. Now,
plus
that's the first step, and then we're going to say plus.
14.001
This is tough.
0.0148, I think.
Yeah, I'm going to put a 0 in front of that. 0,
148.
148. Good. And that's the answer, right? Whatever that answer is, that's the answer. Yeah.
I have a question about getting the 1.48. When you subtract 100 from 98.52, and then you do the same in figures,
Yeah.
I get 2.5 or something. Like, you know where you draw the line?
5, 2.
Or because when you
100. Yeah. Okay. So that's a little bit different. Okay. How do I describe that? Percent abundance. How should I sidestep that? For that percent abundance right there, you want to look at the 100 is not going to be something that limits your sig figs. If you have 100 minus whatever this is, it'll be whatever this number has in sig figs. Okay. That's not going to. The 100 is not it's not limiting your sig figs. For that.
so on the calculator, you just
Yeah.
subtract it.
Yeah.
Oh,
That's just fine. Okay? So you don't need to. That's a good question. That's actually a question I've never come up with. I've never come across in 3 years, but that's a good question.
How many sig figs does 100 have?
How many? Well, in that I just say don't let the 100 limit your sig figs. So just assume it's perfect sig figs. Okay, just exactly 100% because it couldn't be anything else, could it?
Oh wait, well,
Yeah, and then up front.
will we base our sig figs on the percent number or on the open?
Well, let's see right here. How many sig figs do we have right here? We're gonna have 4 sig figs. So this is gonna give us 4 sig figs. How many sig figs are we gonna have over here?
4.
Well,
5.
1, 2, 3. 3 sig figs over here.
Oh,
Holy crap. Now it turns into something else. We've got 4 plus 3. Whatever these sig figs turn out to be,
You use 3 sig
You say use 3.
right. This one's going to be 3 sig figs over here. This one's going to be 4
So
over here.
whatever has less sig figs.
It's the decimal.
Yeah, after you get to this, the decimals will determine the sig figs.
Did we go over?
No. Don't need to worry about that. I know, it's so, but it's good for you. Yes, it is. It's like growing a mustache. Okay, moving on. Not moving on.
Can we do the harder of the X minus one?
Yeah.
Give us
Right.
what you'll give us on the
Also,
test. That's like
Would it
hard.
be like 13.89?
I'll just set up the hard one, okay? How about that? The hard one would be this. I'd say, I don't know what this percent abundance is.
I did
Say
it
the
with
hard one.
Mr. What's his name?
Consus?
No, the physics guy.
Greg.
Mr. Greg.
What
I
about-
told you, remember? I did a reverse with him.
You did the reverse. Good job. Reverse. We did that. Now, let's just say that the average atomic mass for carbon is 12.011 AMUs. Let's just say that. The question now is, what are the percent abundances now for these two isotopes? This is super duper tough. How would we do this? I see 3 people with their hands raised. Let's go with Rishi.
Actually, no, let's not go over.
Let's not go with Rishi. Let's go with Dindio.
Should we use X?
We should use
Make
X.
an equation.
So let's just
We did
have.
the opposite of what we did
Like,
before.
yeah.
You should use, so you get the.
What do you use?
Come on.
12.000 times X.
What?
No, times
And
X.
then you equal it to 12.011.
Okay, let's do that. Yes. So let's do this. 12.000 times X.
Yes.
Okay. Plus. Now what?
14.001
14.001 times
X minus 1.
1 minus X. Right? 1 minus X. That's what you meant. Yes.
Wait, how do you know which one is one?
It does not matter. It doesn't matter. You can try it either way. If you want to test it yourself, you can try it out and you'll get the same
Is
numbers.
it always 1 minus X or X minus
It's always 1 minus X because this is going to be a decimal form, right? It's going to be point something. And it's going to be added to whatever this is, and both of them are going to equal 1.
That makes sense.
Why
Right?
is it 1 minus?
Did we go over this or not?
Like
We did. We did.
the number in the box to the
This?
is that in this box, is it always the remainder of the percentage from this?
No, you can have this one as X if you want, and that one is 1 minus X. You just need to make sure one of them is X and one of them is 1 minus X. Either way it will work. You can try it yourself. It'll work.
Why 1 minus X?
No.
Because if it's 100, then that.
No, because we've already turned it into a decimal form, which would mean that X is something between 0 and 1. It's always going to be like 0.125 or 0.015 or 0.952. I don't know why 5s keep on coming in, but you know what I mean? It's totally lost? Okay. It's going to be something, X is going to always equal something between 0 and 1. It's always in between that range. So whatever it is, it's between 0 and 1.